Hello YouTube, today I'm going to show you how to create a Windows bitmap file from scratch. Let's start. First of all, we are going to see what is the header of the file. The bitmap file format has a header which first field is the signature. Then we have the file size, 4 bytes, are reserved 4 bytes, the offset to the pixel array where the image is coded, the header size, the width and height in pixel of the image, the number of planes and the bits per pixel, 4 bytes for explaining the compression if it is compressed, the image size, intensity of the image, x pixels per meter and y pixels per meter, the number of colors in the color table if there are any, and the important color count. After that, we can see that the image is represented in a pixel array. Well, we have to say that in this file format the bytes are saved using the notation called Little Endian, and in this notation the bytes are rated from the least significant byte to the most significant byte. For example, if we have this value A, B, C, D, E, F, O1 in hexadecimal, in the file it will be saved as 01 EF CD AB. We code this simple image of the height of the image is 16 pixels and the width is 16 pixels too. Okay, so we can start to complete the header of the file. Well, we see that the file size we don't know yet. We will put question marks. Reserved bytes, we will put them to 0. The same to the offset to the pixel array, we will let it and now for the moment, and the same for the header size. Okay, we know that the width of the image is 16 pixels, so if we represent 16 in hexadecimal, its value is 10. So using Little Endian, we write 10000000 as the width of the image. The same applies to the height and to the number of planes. The image will consist only in one plane. Well, we will represent each pixel using RGB notation. So we have in the file it will be saved as 1800. We will use no compression, so for the moment we will let the image size as a question marks. We will write 0 the rest of the fields in the header, and then we are going to start with the pixel array. Okay, well, looking back, we see that we have right in the left the offset. It is the position of each field. So we see that the pixel array starts at the position 36 in hexadecimal. So we can fill the field offset to pixel array as 360000. Another field we can fill is the deep header size, okay, which is the size of the header of the image. It starts in this field, deep header size, and it finishes with important color count in this case. So if we put the number of bytes, we can see that the number in hexadecimal is 28. Well, the colors used in this image are this B6. In the bitmap file, the pixel array doesn't start from the top and goes to the left and then goes down, but instead it starts in the last row from left to right, and then the following one, and so on until finishing the image. So we have to take this into account to properly code the image. Okay, let's start codifying the last row. We see the first pixel is light blue, so the RGB color is OOFFFF. We write it. The following one is a black pixel, so its representation is OOOOO. We write it. The third one is a white pixel, which representation is FFFFF. We write it. And we do the same with the following pixels, obtaining this series of bytes. Okay. Well, we can see that a row has 16 pixels. Each pixel is represented by 24 bits, 3 bytes. There are 16 rows, so we can calculate the image size as 16 times 16 multiplied by 3. If we represent this in hexadecimal, the value is 0300. And the total size of the file is the number of bytes of the image plus the number of bytes of the header. So the total amount is represented in hexadecimal as 0336. We can complete the fields in the header, image size using little endian notation, and file size using little endian notation too. And what we have to do is to code the rest of the rows in the image. So for the second row we have this representation, this for the third, fourth, fifth, sixth, the seventh row, the row number 8, 9, 10, 11, 12, and we continue coding all the rows of the image. So what we have to do is to put all the things together using an hexadecimal editor and write it to a file and see if the result is the one that we are looking for.